All right, 13.3 part 1 is geometric sequences. We talked in 13.2 about arithmetic. What did we know about an arithmetic sequence? Let's talk about it for a second. And we had an arithmetic, whatever you want to say it, or arithmetic. When we had arithmetic, what was the shape? What did I tell you to equate arithmetic with? A linear line, good. And you guys found the common difference. What you added or subtracted every single time to get from one term to the next, correct? What did we also call that? Since it was a linear function, we called that slope. All right, so there's two kinds of sequences that we talk about. We talk about arithmetic ones, which are linear, and then we talk about geometric. And geometric is not a linear function. We equate that with an exponential function. So when I say the word exponential, what do you think of? Exponent, okay? So this rule, this function that we're going to talk about, has an exponent in it. You're going to talk about the common ratio right here. We are not going to add or subtract to get to the next number. We're going to multiply. So you're going to need to know the common ratio. How did I get from one term to the next in a geometric is called a common ratio. And by finding that, that is going to be what you multiply every time to get from one to the next. It's not going to be a slope. It's not rise over run because it does not make a straight line. It's an exponential function. So it gets big in a hurry and it gets small in a hurry. Now, when I say you multiply to get to the next one, so if I said to you, okay, I start with 2, and then 4, 8, 16, ... How are you getting from one number to the next? You're timesing by 2, right? You could say, well, you add 2, and then you add 4, and then you add 8, but that's not a common thing. That's just a pattern that you see. But what do you do every single time we're multiplying by 2, right? So that's how you find the common ratio. What if I said you went from, let's say, 10 to 5 to 5 over 2? You divided by 2, right? But I told you guys that your common ratio is always going to be multiplication. So when you notice that a sequence is getting smaller, your common ratio is not going to be divided by 2. What would your common ratio be here? You multiply by what? 1/2. When your sequence is getting smaller in numerical value, you are multiplying by a fraction. So make sure you guys understand that your common ratio is never going to be divided by something. If you notice that you are dividing by something, you actually are multiplying. You're just multiplying by a fraction. Does that make sense? Okay, so here is the arithmetic rule that we used yesterday and we used the last few days. A1 plus n minus 1 times your common difference, right? That was our arithmetic rule. And you guys wrote the rule for the nth term, and then you found the whatever term. All right, we have a rule, we have a formula for our geometric, and this is it. It's very, very similar. You still have to find the first term, that's your a sub 1. Instead of your common difference, you find the common ratio. And then in the exponent is where you have the term number, and it's always n minus 1. This is the formula that you guys need to memorize. You need to know this. You will not be given this on your test. You have to know this formula. Now, I wrote in purple, you see it says common, it should be ratio, not ration. Not sure why I put that. Common ratio, how do you find it? Sometimes it's real simple. You can just look at it and just see, oh, I multiplied by 3. I multiplied by this. Sometimes you can't. So the way that you can always identify what the common ratio is you take a term and divide it by the one in front of it. So I made an example, said take the third term divided by the second. Take the fifth term divided by the fourth. You'll always be able to find the common ratio in a geometric if you take the term and divide it by the one in front of it. Just a little thing to hang on to. All right, so let's look at some examples here. You're going to have some where it just gives you, hey, here's the first term, here's the rule. Go ahead and write it. So in this case, they give you all the information you need. So if I look at this, I say, okay, they told me it's geometric. That means I'm going to use this formula, a sub 1 times r to the n minus 1. Guys, you got to be able to use your calculators to know how to input some things. So the first thing we do is write the rule. What is the first term that they told you?
3.
3. So I have 3 times, what's your common ratio? 2 to the n minus 1 power. This is the rule. When they say to you, find a sub n, find the rule for the nth term, whatever. That's the rule. So now if you're going to find the 17th term, again, these numbers get big in a hurry, they get small in a hurry, and I just made this example, so I don't think it works pretty, but we'll go. Oh, wait, I think this one does. I don't think the next one does. So if I'm going to find the 17th term, I'm going to take my rule, and it's 3 times 2 to the 17 minus 1 power. Do I multiply 3 times 2 first? No. Guys, exponents before multiplication. So as we simplify this, I have 3 times 2 to the what power? 16th power. So what do I do first? 3 times 2 or 2 to the 16th? 2 to the 16th. In your calculators, go ahead and tell me what 2 to the 16th power is. What's 2 to the 16th? 65,536. Okay. And then multiply that by 3 for me.
196,600.
608. Okay. So the 17th term for this geometric sequence is 196,608. Does anybody have any questions about how we just did that? All right, let's go to the next. That should be a little hint to you that you're like, oh, wait a second, the sign switch here. So I have to find my first term. I have to say a sub 1. What's my first term? 2, okay. And then I have to find my common ratio. Well, how do you find the common ratio if it doesn't just jump out in your face? Okay, see what it goes by. So how would I do that? Okay, you're multiplying by -5. Some of us don't just look at that and see that. So take any term in the sequence except for the first one. Take 50. What's 50 divided by the term in front of it? -10. What is that? What's 50 divided by -10? -5. Now, if you're not 100% sure, if you're not super confident, I'm not really sure, then take take 1250. And divide it by what? -250. What's 1250 divided by -250? -5. So you find that your common ratio is -5. So now you have enough information to write the rule. So your rule is going to be a sub n equals, my first term is 2 times -5 to the n minus 1. There is your geometric rule. Now if I'm going to find the 24th term, where do I plug in 24? To the n. So the 24th term is 2 times -5 to the 23rd power. Now, when you do this in your calculator, guys, -5 to the 23rd power is a gross number. It comes out to some scientific notation. I will do my best to not give you a question on the test that comes out to scientific notation. But understand, what do you do first in your calculator? -5 to the 23rd, then you multiply by 2. Some of you are going to make the mistake. You're going to do the multiplication first and then raise it, and then it's completely wrong. So make sure you guys understand exponents come first. Yeah? All right, the next one. All right, now we come to fractions. All right, again, they tell me it's geometric. So I'm going to say, okay, I need the first term, which happens to be 1. Great. And I need my common ratio. How do you figure out what the common ratio is? Take one of the terms. I'm going to take 1 over 27, and I'm going to divide it by what? 1 over 9, the 1 in front of it. Guys, when you divide fractions, you 1 over 27. Change the division, and I flip it, and it becomes what? 9 over 1. And then when we simplify this, what does this equal? 1/3. Again, if you're like, oh, I'm not super duper sure, that's fine. Take another one. Take 1 over 81 and divide it by the 1 in front of it. 1 over 27. So we're going to keep, change, and then flip. 27 over 81 simplifies to 1 over 3, right? So your common ratio here, R, is 1/3. So we can write our rule. Go ahead and write the rule. A sub n equals the first term, which is 1, times 1/3 to the n minus 1 power. Do you have to have that 1 out in front? No. Do you have to have the 1 in the exponent? Yes. Now look, guys, we're going to find, excuse me, the 9th term. So I'm going to say a sub 9. So I have 1 times 1/3 to the 9 minus 1 power. When I simplify this, this becomes, okay, the 9th term is 1/3 to the 8th power, correct? What did the directions say right here? What do the directions say? I just circled in yellow. No decimals. I want you guys to be aware, if you start off with a fraction, your answer needs to be in a fraction. Most of your calculators will not convert for you, so you have to understand algebra rules. When I have an exponent in a fraction, this 8 goes to the numerator and where? To the denominator. So when I simplify this, this becomes 1 over 3 to the 8th power. What is 3 to the 8th power? 6,561. All right, so think about this, guys. When I told you at the beginning here, geometric gets big in a hurry and it gets small in a hurry. They originally gave us the first, second, third, fourth, the first 5 terms. They asked me for the 9th. They asked me for one that was only 4 spaces away. Look, we went from 1 over 81 to 1 over 6,561. Your numbers are going to get big in a hurry, and they will get small in a hurry. You will have to deal with fractions and stuff, so just be aware of those things. That make sense? All right, let's do the last one. We're going to talk tomorrow about, like, hey, I gave you this term and this term. Figure out the common ratio, figure out the rule, all that good stuff. It's a little harder, and then we'll do partial sums of infinite and finite sequence series. All right, let's look at this question. It says, find the common ratio, find the first term, write the rule, find the 8th term. So we got to do all the stuff. Well, I can already tell what my first term is. What is a sub 1? What's the first term of the sequence? 5. Good. What is your common ratio? Times 3. If you didn't just see it, just take one of the terms, 15, and divide it by the term in front of it. Take 45, divide it by the term in front of it. It'll come out to 3. So now if we write our rule is a sub n equals, my first term is 5, times 3 to the n minus 1 power. There is your rule. Questions? Anybody? All right, so if I'm going to find the 8th term, I have, what is the 8th term? I'm going to say 5 times 3 to the 8 minus 1. So as you work this out, this is what I want to see on your web assign. This is what I want to see on a test. I have 5 times 3 to the 7th power. Some of you are going to multiply it. Say 5 times 3 is 15, and then raise that to the 7th power. Is that correct? No, you need to evaluate this first. What is 3 to the 7th power? What's 3 to the 7th power? 2,187. And then multiply that by 5. 10,935. So let's look back at this again. All right, they gave me the first, second, third, fourth. They gave me the first 4 terms. The 4th term of this sequence was 135. I moved 5 terms over, and I'm at 10,935. When I tell you geometrics, guys, get big in a hurry and they get small in a hurry, don't be alarmed if your number is really big or if your fraction is really small. Don't freak out about it, okay? We good? All right, so your web assignment is like 24 questions. You can get, I think it's 1 through 12 or 1 through 14 done right now before you leave. You guys have 20 minutes. There's no reason you don't have at least the first half done before you leave.